Hi everybody, welcome to our first video on the subject of finding volumes using integrals. We're going to start with a very basic example, something you probably saw in elementary school. Well, maybe not the calculus part of this, but at least the formula you did. So say I wanted to find the volume of a cone, and I'm going to pretend that this cone has fallen over. So when it fell over, this is what it looked like. Okay, so I happen to know the end point here was h, and at this point the height is capital R, which also happens to be the radius of the circle on the end of the cone. Now I'm interested in finding, I said, the volume of this, and I'm going to assume that we don't actually know the volume formula that you probably learned in 4th or 5th grade. Okay, so how can we recover it? Just like everything else with integration, we're going to sample. Okay, so maybe I chop this axis up into little points. Okay, and then at each of these points, I'm going to take a cross section of the cone. Now, cross section, imagine I drive a plane through here. Every time you take a cross section of a cone, you're going to get a circle. So say at this point, for example, if I took a cross section, I'd end up getting that circle right there. Okay, now I extend this out a little bit, and when I extend it out, I'm going to get a nice cylinder. Okay, so I get this cylinder, and I'd like to know what the volume of that cylinder is. Okay, so with a cylinder, there's a really nice way of computing that. Let's draw that over here. And I'm going to take this cylinder and kind of rotate it up. So if I have a cylinder, well, what that really means is that I had a circle and I extended it upwards. By how much? Well, whatever the height of this is. Okay, a different h from over there. Okay, and if I want to compute the volume, all I need to do is take the area of the base. So let's take that A here. So A, which is the area of the base. Area of the base. And I multiply it by the height. So times h. So that's the height. And this actually works with any type of cylinder. They don't have to have a circular base. They could have a square base, a triangular base, or even just some funny shape as a base. As long as you take that base and just translate it up, then the volume will still be the area of the base times the height. In this case, very, very easy. We have a circular base. How do we find the area of a circle? Well, that's going to be pi times the square of the radius. So if that radius is r, then that's going to be my area, and of course I still multiply by the height. So what about this pink cylinder over here? Well, the height, that's going to change as I add or subtract cylinders from here. That is, if I take finer and finer partitions, these cylinders are going to get thinner and thinner. And in the limit, well, that's when we get our little dx. Okay, so I'm just going to draw it in here as if we knew the height already was going to be dx. So then the only question is, well, what's the area of a base? And we know the area of the base is pi. Well, okay, that's just a constant, times the square of the radius. Okay, so what does that mean? Well, it means I'm looking for this distance from the center up to this function. So I just need to know how far this distance is, right? If we were all the way at the end, it would be capital R. Well, we're not all the way at the end, but there is going to be some distance here. And so I know whatever that length is, we'll call it little r for right now. Whatever that length is, I know that the volume of that pink cylinder is going to be pi little r squared times the height, which we called dx. Okay, fine. Let's see, how can I get this r? Well, let's take a look at this curve. It's not really a curve, it's a straight line, and it goes through the origin, which means Well, if we use slope-intercept form, the intercept is 0. So we just need the slope of the line, and we can write down the equation. Y equals, what's the slope? Well, we do know that at this point, it's r high, and it's h over, which means the rise was r, the run was little h, and so the slope must be big R over little h. So this is r over little h x plus 0, because it goes through the origin. Okay, so if I'm at a coordinate x, then this height r is just going to be r over h times x. All right, so I can put that into my little volume formula, and I get pi r over h times x squared dx. Neat. Okay, that just gives me one single cylinder. But of course, I sampled at all these different points, and I built a whole bunch of other cylinders. You know, I built another cylinder over here, for example. Yeah, like that. Okay, and I want to add all these up, and of course, then I take the limit as the thickness goes to 0. Okay, so of course, every time we do this, it's the same story. We're going to get an integral. What am I integrating from? Well, the x starts at 0, it ends at h. So my total volume should equal the integral from 0 to h. And then what's going to be the volume of each one? Well, it's this guy here. First, well, there's a pi in every single one of them. So I can pull that out, pi. And then I get, let's see, well, there's an r squared, h squared, and an x squared. Well, I guess there's more constants to pull out. R squared, h squared, x squared, dx. Okay, well, let's pull those constants out. So now I have pi r squared over h squared. Now I need to integrate x squared. Well, it's easy. It's x cubed over 3. Fine, x cubed over 3, and we evaluate between 0 and h. Okay, at h, we get h cubed over 3, and at 0, well, we just get 0. So in total, we have pi r squared over h squared times h cubed over 3. And there's a little cancellation we can do, and we end up with pi over 3 r squared little h. Okay, so we've now recovered the volume formula for a cone that you found probably in elementary school. All right, it says if you know the radius of the top side of the cone, if you know the height, then you can compute the volume as pi r squared h over 3. All right, in the next video, we'll handle some more complicated situations that involve taking a function and rotating it around an axis. The cool bit is the same idea is going to work, and it's going to come right back to this idea of finding the volume of a little cylinder. All right, we'll see you next time.